Picture an industrial pipeline moving thousands of gallons of heavy crude oil, suddenly forcing all that volume into a delicate glass filtration tube. It shatters. In enterprise software architecture, we see this specific structural failure mode repeatedly. Organizations deploy SAP Analytics Cloud for enterprise planning, only to experience severe performance degradation almost immediately. The symptoms are consistent: sluggish input forms, critical data actions time out, and models suffered excessive data bloat. These issues are rarely software limitations. Instead, they result from a specific engineering anti-pattern. When a specialized planning product is treated as a generalized data warehouse, the enterprise planning capability cannot scale. This topology shows the root of the problem. Raw historical data and transactional line items bypass intermediate layers and flood directly into SAP planning. This direct pipeline forces SAP to act as both an ETL engine and a data warehouse. Ingesting massive volumes of unrefined data puts a strain on the multidimensional in-memory processing that SAC relies on for performance. Correcting this requires a specific standard, a strict boundary between a data platform and a data product. The data platform, SAP Datasphere, is the engine for enterprise-wide data ingestion, relational transformation, and master data governance. The data product, SAC Planning, is a specialized environment that consumes curated data to deliver specific outcomes, like a revenue forecast or a workforce plan. By decoupling data harmonization from the planning layer, the system remains stable enough to integrate disparate departments into a single, cohesive planning cycle. This boundary is built into the SAP Analytics Cloud platform itself, which bridges historical reporting with forward-looking decision-making. The BI track handles passive, read-only analytics. It is designed for live querying and descriptive dashboarding. The planning track is an active environment. It requires multi-step computational logic, scenario modeling, and writebacks to core systems. Because users must actively disaggregate data and run simulations, the planning track demands a data structure optimized for write performance, not just descriptive viewing. Feeding BI-level transactional depth into a planning model creates architectural debt that slows down every user interaction. Data transformed inside a bloated planning model becomes locked within an application layer, creating a logic silo disconnected from the rest of the enterprise. Recognizing these two distinct tracks allows architects to prepare data based on whether it is meant for descriptive reporting or predictive simulation. To manage this, we must establish the exact operational boundary between the platform layer and the product layer. For Datascope, Datasphere owns enterprise-wide actuals and historical depth. SAC Planning owns only Ather-dated drivers and plan versions. For operations, Datasphere handles ETL and relational modeling. SAC handles input enablement, disaggregation, and simulations. For logic, Datasphere executes joins and data harmonization. SAC executes data actions and allocation rules. For flow direction, Datasphere provides the baseline actuals. SAC consumes that data to generate forecasts and write budgets back to the core. Enforcing this separation frees SAC from performing heavy data joins. Its in-memory engine can dedicate all available compute to plan iterations. This eliminates logic silos, allowing the same harmonized actuals to serve both BI stories and planning models simultaneously. The SAC Plans framework operates on a core principle. Planning models must not replicate the structural complexity of an ERP. Data must be distilled before it enters the planning layer. Datasphere performs the heavy aggregation, stripping away unnecessary line item dimensions upstream. This enables driver-based planning. The streamlined model captures only the essential drivers, like volume and rate, necessary for decision-making. Minimal models make logic transparent. Planning calculations become readable by the business team, rather than being hidden in technical code. This minimalist design allows an organization to move away from rigid annual budgets and toward agile, rolling forecasts. This is the enterprise planning ecosystem in motion. S/4HANA feeds raw data into Datasphere, preparing the semantic assets. Datasphere provides real-time actuals to SAC BI and aggregated drivers to SAC Planning. Finalized plans are sent back to Datasphere, or the ERP, for tracking. This architecture enables immediate variance reporting, comparing real-time actuals against newly generated forecasts without system latency. Eliminating architectural debt requires SAC to function as a data product. By strictly adhering to these framework-driven boundaries, organizations achieve the critical structural stability required for integrated enterprise decision-making.